Alright, I have got the answer key partly filled out here, but I'm going to explain it. Unproven statements accepted as true. These are postulates. They're our starting points in our reasoning game. You can also call them axioms, alright? Axioms is an older term. But proven statements, they are the theorems, alright? Those are proven conjectures, okay? A statement is true in both its original if-then form, that's its conditional form, and in converse form, that's a biconditional statement, okay? Biconditional. And a quadrilateral with two pairs of consecutive, that's one after the other, congruent, equal sides is a kite. Know your definitions. This is one of about 10 or 12 definitions you should know. Here's another one, a triangle that has base angles that are congruent. That's a property. That's an isosceles triangle. The definition is that the sides are congruent, but a property is that the angles are congruent. Alright, if you have two parallel lines that are intersected by a transversal, the co-interior angles are sometimes congruent. That's when they both happen to be 90 degrees. That does not happen often, but it can happen, so sometimes is the best answer. Okay, so if we're going to assume that this is true, that all zoids out there in the universe eat cloids, we can write it in symbolic form that z implies k, and when we write it in conditional form, that's simply using the words if and then. If the animal is a zoid, then it eats cloids. Okay, so again, in symbolic form, z implies k. That is valid because we're assuming it's true in the beginning. If it is true, then in converse form, we'd say if a cloid eater, so if it's a cloid eater, then it's a zoid. And you could say if it eats cloids. I'm just doing that to make the k and the z part a little more clear. K implies z is the converse. I've swapped the z and the k. That's invalid though. That is not necessarily true. If I'm inside k, it does not mean I'm inside z. But if I'm inside z and I'm a zoid, I am definitely going to eat cloids. Alright, so inverse is when you put knots in front of the original statement. Go to the original statement, put those little tilde things that are not. If it's not a zoid, then it is not a cloid eater. It does not eat cloids. And that is invalid. Inverses are invalid. Converses are invalid. Contrapositive is when you do the inverse of the converse or the converse of the inverse, and that is valid. And that's just simply saying, hey, look, if I'm out here, I'm not a cloid right there, then I can't be in there in the small world of zoids. All right? So just write it like that. Okay, number 8, here's a chance to use our logic and our reasoning. I would translate each one of these into letter form. Translate each one of these into letter form. If Kim does not go to the movies, that's no Kim, then we can say that's not going to be Lou. If Kim does go to the movie, then Mike will go. So Kim implies Mike. Either Nancy or Oliver, they're definitely going to the movie. So that's Nancy or Oliver are going to the movies. If Mike goes to the movie, then Nancy will not go. So Mike goes, that means we're not going to have Nancy. All right? Well, if either Nancy or Oliver go, then Lou will go. So we could say then N-O or O. That implies Lou. That's like a slightly new wrinkle on what we've done. I'd be curious to see on a test if you can write this down based on what we've done before. So we've never seen one just exactly like that, but hopefully you can figure that out. Well, we know that this is a true statement, so we know that Lou is going. So in our little proof, with my statements and my reasons, I'm going to start off with saying that Lou goes. And I know that from clue number 5 and number 3. And then that's direct reasoning. That's my original direction of that if it's direct, if I know that either of these two are going, then Lou goes, and they are going, so I can use those two statements to say that Lou goes. Well, if Lou goes, then we know that Kim is going to go because of clue number 1 and then what's called indirect reasoning. Okay, that's the contrapositive, or you could write contrapositive. Okay, that's the fact that you can take any original statement and do the inverse of the converse, and that would be also saying that L goes, so Kim has to go. Well, L is going, so Kim does have to go. All right. Well, then M is going because in clue number 2 it says that if Kim goes, then Mike will go, and that's direct reasoning from clue number 2. If Mike goes, then Nancy will not go. So we know that Nancy's not going, and that's clue number 4, and that's also direct reasoning. All right? So there you go. You know who's going and who isn't, and that's written as a little proof. Okay, problem number 9. Which, if any, of the following triangles are congruent? Well, if we know that these are parallel because of that, then we can say that this angle here is the same as that angle there. We can also say that vertical angles say that these two are the same. So I could say triangle AMB is the same as triangle DMC. And that's because A is between the 1 mark and the no mark side here. And the 1 mark and the no mark side there is D. So the letters correspond. And the reason then is angle, angle, side. Okay? But somebody else could have said, oh look, well these are congruent because of alternate interior angles, and then they could have said angle, side, angle. So I would accept either one, but make sure you mark the drawing so that it matches up with what you're saying. Okay? Then this one here, we're asked to say why angle C is congruent to angle E. All right, or that we're told angle C is congruent to angle E, and we're asked to prove why triangle AMB. So A, oh, there's a little bit of a typo, MB. I think that is supposed to be AEB. AEB. All right, well, there's a little bit of a hitch. Sorry about that. But if I separate these triangles, hopefully it's fairly clear which ones are congruent. All right, these are both right angles. They're going to be equal. This short side and that long side. And then if we know that this angle here is congruent to that angle there, this is a case of angle, angle, side. Angle, angle, side. And I just need to get the congruent statement correct. With A is the right angle, so that's going to be congruent to itself. E then is the one that we know is congruent to angle C, and then B is the one that will be congruent to F. So ACF. All right?